And welcome everybody. Let me share my screen and talk about the plan today. So the plan of the day is, as always, I'll start out with any questions you might have. And then I'll review discrete versus continuous variables. That was discussed in chapter 2, I believe, very quickly. So you may or may not remember them, but we'll talk about them. Then we'll talk about probability distribution tables for discrete variables. And that's a way of kind of organizing the stuff that happens. And then we'll get into two very important topics: the expected value and the standard deviation. So that this is going to be today's a 2-chapter day. That shouldn't make you get too scared, because it's 2 chapters because each of the 2 chapters are not that long. In fact, I took some of the sections off a while back, and we just do 2, a little bit of it. But we'll do expected value and standard deviation and binomial distribution. Those 2 things happen in chapter 4. And then we'll talk about continuous distributions, okay, as opposed to discrete distributions. And we'll get into not the most important one, but the easiest one. And that's what you want to do when you're starting something off, is you want to look at kind of easy examples. And the easiest example of a continuous distribution is a uniform distribution. And we'll look at how that works. And we'll also look at the mean and the standard deviation of a uniform distribution. So let me ask you, are there any questions from any of you? This is a great time to ask questions if you have them.
Is there a lot of stuff to cover? Because I could ask my questions in Q&A.
You can ask questions here. That's the whole point.
I had a question wrong in my test, and I actually haven't been able to figure it out conceptually. And the question was something like 68% of the population got vaccinated or something like that. And then, like, if you were to draw 4 people at random, what is the likelihood that one of the 4 would be vaccinated or something? It wasn't vaccinated, but it was.
It probably said at least one of the former, right?
Yeah, at least one of the 4.
That's very different. Yeah. Yeah. So the easiest way of doing that is complements, because the problem with at least one of the 4, that could be 1, it could be 2, it could be 3, or it could be all 4. And that's a lot of work to do all of that. So instead, you say, what's the complement of that? And that would mean none were vaccinated. Does that make sense? If not at least one of the 4 was vaccinated, that means none of them were vaccinated.
Oh, I kind of understand that. Okay.
And the rule of complements say you take 1 minus the probability of the complement. So the probability of the complement, so the complement means none are vaccinated. So if 68% are vaccinated, then 32% are not vaccinated, right?
Yeah.
So the first person not being vaccinated, that's 0.32 for probability.
Correct.
The second person is also 0.32. The third person is also 0.32.
Right.
And the fourth person is also 0.32.
Okay.
All right. So if you want to find the probability that none are vaccinated, that'd be 0.32 times 0.32 times 0.32 times 0.32.
Right.
Or 0.32 to the 4th.
Yes. Well, I did 0.68 to the 4th, and that was wrong.
Right. We're not done yet. There's one last step. Since we're using the rule of complements, you take that and you subtract from 1. So you go 1 minus 0.32 to the 4th.
Fuck.
Which is different than 0.68 to the 4th. Does that make sense? So they are different.
Yeah.
If you do 0.68 to the 4th, that would be the probability that they're all vaccinated.
Oh, that's what I calculated.
Yeah.
Okay.
Yeah.
I only half get that. I got to go back and look at the rule of complements. And if I have more questions, I'll ask you again.
Yeah. And I will let you know we do use the rule of complements. In fact, pretty much a lot of the chapters of this book and the rest of the class use rules of complements.
Okay.
So it's one you want to keep in your head. There's some things we really won't touch again, but that's not one of them.
Okay, I got you. Thank you.
But good question, again, very statistics question, and it's not easy. So let you know, this morning, you might have noticed, you might not have, is I graded the essay parts, or the writing part. The last two questions you had to write a bunch. And so I graded those. So if you looked at your score before this morning, then you should look again. Because what happens is that I think the computer automatically gives you a 0 until I grade it. And then I add points to it. So, it's only 2 problems out of the 14 problems, but still it helps. And the 2 problems are worth more than, each of those problems are worth 3 points and the rest are worth 1. So just let you know that it is a, chunk. So if you were crying a whole lot after you completed the exam because you looked at your score, you should look again, because it almost certainly went up, unless you left those 2 problems blank, which very few did. So that's just a note in terms of, what I did this morning. And so that's all set. So you now have kind of an idea, a more solid idea of what exams look like, because that's what the exams are all going to look like. The only difference is that the next exam is going to have some review stuff, like half review stuff and half new stuff kind of thing, or maybe a third of the review and 2/3 of the new for the next exam. But it's the same style, if that makes sense. Okay. Any other questions? Any other questions?
Will all the exams going forward have a review element?
Yeah. Yeah, so they'll all have a review element. Obviously, this one didn't, because we're at the beginning of the class. So this one was just the first 2 weeks, because that's all we got. There's nothing to review. But the next one will have the review element of the first 2 weeks, and then a bigger chunk of the next 2 weeks. Does that make sense? So that's how that's how I've set them all up. So that's how they look. And by the way, they just randomize problems that you have on the homework. Okay. Except for the last 2, and those are essay problems. And that's how they're all going to be. And hopefully that works. I did it last quarter for the first time, and everyone thought it worked well. That doesn't mean it was easy, but they all liked it. They all liked it better than just giving a midterm and a final, where it's real high stakes for those 2, and that's the class. So I've gone this way, and I think I'm sticking with it, because, but I'm happy to hear suggestions.
Do you provide extra credit assignments in this class?
We don't have extra credit assignments in the class, no. No, but the key is work hard, and then you should do well. And things like the project, there's no extra credit, but if you work on it a lot and ask questions as it goes and submit your draft, then your project should go well. Whereas if you don't, and you just wait till the last day and submit your project, it usually doesn't go well. Just a warning. So it's the kind of thing where you definitely want to, I hopefully already have a lot done on, as in at least your project idea. And I've done a lot of communicating via the project one discussion board on whether the projects will work. You should also look at what I've commented on other people's questions, because that'll give you an idea of what goes right and what goes wrong. Does that make sense? So that's why I have it on the board instead of email, is that way you can gain from the information. Other questions?
Are we able to review the exam?
I think so. It's a funny thing is, I don't know, because I'm not a student. Let me ask you all, if you haven't reviewed the exam.
You can review it. Oh, wait, never
You
mind.
may not be able to, but I'm not sure. Okay, if not, what I might be able to do is change the settings in a week.
Okay, that'll work. I just want to learn what.
But if I change the settings in a week, don't change the answers to it, or that could mess things up badly. You could lose points, and you don't want to do that. So it'll allow you to look at it. So if you can't look at it, let me know, and then I'll change settings in a little while.
Or maybe if it's possible, you could give the ability to look at those answers with your Borrelio, and then if we have a tutoring session with Borrelio, maybe he can go over the exam with us, so that we, it doesn't, there's no possibility of us changing the answer. So like if he shared his screen, then we wouldn't,
Yeah,
wouldn't
I'll
mess
tell you
up
the-
our score.
I'll tell you the bad news. He doesn't have access.
Okay.
Yeah, it turns out the exam, it's very complicated. Remember, I'm a computer programmer, and the exam is on a different platform than the rest of the class. And you don't even notice that when you do it, but it's really complicated, and Brawley doesn't have that access. It's complicated. It's too complicated to talk about it. In fact, it's not that it's private. It's just it's a lot of complications. If that, yeah. So I'll see what I can do in a week, and you might be able, and then you'll probably be able to see it. Okay, but I have to give it a few more days, at least. Other questions? Okay, and that's also why I put the comments. You can look at my comments, because that's in Canvas. Did you guys see comments? Yeah, you should be able to, that you should be able to see. If not, let me know, because you should be able to see that. Okay, all right, well, let me talk about the new stuff, unless you have more questions. Okay, because I'm always happy to answer questions. We can answer them after 2, and also office hours, which is in a little while. And in fact, I want to mention one more announcement. My office hours on Friday, which I think no one's gone to anyway, but if you go to it, they're going to end about 10 minutes early. So sorry about that. But again, most people don't come on Friday anyway, but there's a reason for that. I got a call from Compton College, actually, and they want me to talk to their faculty, Zoom talk, to explain how they can go to free textbooks and free everything. So I don't know if I think I mentioned that that's like been my mission, and it's for you, and you've got it. But now all the other colleges are coming to me and say, can you explain how you made it happen? So I'm making it in the whole state of California. That's the idea. So I'm going to be finishing my office hours about 10 minutes earlier on Friday, so that I can make, save literally 500,000 people at Compton College, $500,000 at Compton College for students that I don't know. Okay, so just a note. So if my office hours, if you come in at the very last moment, I won't be there, but I will be there for the first 50 minutes or so, something like that. Okay, so let's talk about continuous versus discrete variables. Okay, and this happened already. This is a review. So, but let me remind you what the definition is. And that is a discrete variable. Let me make it bigger so you can see it better. That's one thing I've learned, is that font matters. A discrete variable is a quantitative. Who remembers what quantitative is? Very important for your project.
Numbers.
Yeah, so that means the answer to the survey question, or the data that you write down when you write down a list of things, will all be numbers. Okay, so it's a quantitative variable. That's the first thing. So it's not the yes, no question. It's not what's your favorite color. It's a number answer, like things like how many shoes do you have? Okay. Whose set of outcomes can be displayed as a list. Okay. So just to note, this is pretty important. I learned this, actually, believe it or not, in something else I taught. I don't know if you remember. What are the 3 things I've taught in my life? The 3 main things? Math is one. I think you know that. Math and stats. Okay. One other was karate. And the third one was English, but EFL, which is not the same thing as ESL. So I taught this in Japan. Actually, I taught a little English in Japan. And I actually learned English as I taught English. And that happens when you have to explain English to someone who doesn't speak English. I don't know if you ever had to do that. One thing I've learned is that we have grammar that goes through discrete versus continuous. So the grammar you typically use for discrete variables in a question, let me write this down, is how many. So if it's a how many kind of question, okay, it's not perfect, but it works real well for a lot of types of things. If you can reword it as a how many, then that's almost always a discrete variable. So that'd be like, how many pairs of shoes do you own? Okay, and you could list all the possibilities. Okay, If you're really weird, you can own 0 pairs of shoes, but that's probably not too many. How many, and you could have 1 pair of shoe, you could have 2 pairs of shoes, 3 pairs of shoes, 4 pairs of shoes, and I could list it. You could have 150 pairs of shoes, and there's gonna be a certain highest number that anyone has, and that's a list of numbers that you could have. Does that make sense? How many siblings are in your family? That's a how many, okay? Whereas a continuous variable is the opposite of that. That's when you can't list it. And as I see in the chat, for that one, it's the how much. So that's things like how much money, or how much do you weigh, I think is a better way. Okay. And I weigh 171.23157 ... pounds. Do you see? You cannot list the exact weight that anyone could possibly be. Does that make sense? Okay, another would be things like how many cars have you owned in your life? Okay, that you could list all the possible number of cars someone could have owned. Okay, so just a note, a discrete variable doesn't mean the answer has to be a whole number. So let me ask you, you can put the chat box, how many siblings, including yourself, are in your family? I'm usually the only one that has this weird kind of answer. Okay, I'll put it in the chat box and see if you understand. Could that happen? 4.5? Yep. There's my step sibling, Lara. She's my step sibling. I call her a half sibling because that's how it works. Okay, but you can't have 4.137 siblings in your family. Does that make sense? So you can still list all the possibilities, even though there's some fractions that could happen. And that makes it discrete. Any questions on the idea of discrete? Okay, so for discrete variables, again, the biggie is that you can list all the possible outcomes, which means that you can create a table where typically the first row or column, however you want to make your table, is all the different outcomes that can be done. And the second row or column are the probabilities of those outcomes occurring. Okay, so for example, you can, in fact, I got one right now. It happens every year. I get a Stellar's Jay. I don't know if you guys know what those are. A lot of people think they're blue jays, but they're not. They're cute little loud birds, and they always have a nest in my house. And you can ask, how many eggs is my Stellar's Jay gonna lay this year? Does that make sense? And that's definitely discrete. Okay, that's one of those, by the way, you can't do halves. You can do half siblings, you can't get half an egg, not for a bird. But the other thing you can also do is, if you're a biologist, which I'm not, by the way, but biologists could figure this out, is they could say, well, what's the probability that a Stellar's Jay is going to lay no eggs in the nest? Okay, probably a small probability because they usually lay eggs. How many, but then what's the probability of 1 egg? What's the probability of 2 eggs? What's the probability of 3 eggs? And there's probably a maximum number of eggs that Stellar Jays would lay, even for like the super Stellar's Jay, right? Might be 7 eggs, I don't know. Most I've seen is 5 in my in the nest that they put up by my house, which is kind of cute. So you can talk about the distribution table that gives the number of eggs. That would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or something like that. And then the probability of each of those happening in the second row or the second column. And you get to choose whether you make it 2 columns or 2 rows. Any questions on the idea of a discrete variable? Okay, so here's an example. And let me make it bigger. Okay, so a car salesman gives a $10 gift to every customer who test drives a car. Okay, and by the way, that's real common. A lot of times they give you something. Sometimes it's a gift, sometimes it's money, whatever it is. If you come into their dealership, I don't know if you heard of that, but that's real common. Okay, and that's whether you buy it or not. They give it to you just for coming. Okay, 12% of all customers who test drive a car purchase the base model, okay, of the car, and that results in a $200 commission for the salesperson. Okay, which is good, by the way, because look, if salesperson had to give away $10 but made 200, then they made 190 bucks. 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. So the idea here is we want to come up with a probability distribution table. So notice that this is definitely discrete, because what you're interested in business, what is everyone interested in business? In one word?
Money?
Money, but I'm thinking a little
Sales?
Not sales, there we go, profit. It's all about profit, right? Okay, it's profit. If you're not making a profit, you have a bad business. Does that make sense? Okay, if it's business. So profit is everything. And in this case, your X value, or the variable, will be the profit. So for this case, the profit, one of the possible profits will be $190. How did I get that?
200 minus 10.
Yeah, 200 minus 10, because you got your $200 commission, but you had to give away 10 bucks. Another possible profit will be $290. Okay, and that would be if they got the deluxe model. Is that it? What do you think? Any thoughts? Okay, I don't see everyone jumping in.
Well, they would, some people would lose $10 because not all the people would buy cars.
Yeah, in fact, the most common profit will be negative $10. So you're right, lose $10, but let's write that as a number. That would be negative $10. Is that clear? So negative 10 will also be a possible value of this variable. So there are three possible values of the variable. You can definitely list three numbers, and that makes it discrete. Any questions on that? So because of that, enter, I can draw what's called a probability distribution table. I'll put that maybe in red, because that's what we're doing. That's the main thing here. So what you do is you write down X, you write down P of X. P stands for probability. Okay. X is the value that can happen. So as we mentioned, one possible value is 190, and that would be if they sold the base model of the car. And notice that the 12% of the customers do the base model. So you have to know how to turn percents into decimals. Probabilities are decimals, and that is 0.12. Okay. Then 8% got the deluxe model. So that's 0.08 for the deluxe model. So don't forget, always when you're given a percent, you want to turn to a decimal, you got to move the decimal over twice, so we get that 0 there. It's definitely not, you have to do 0.08. All right, well, for the nobody coming, I got 0.8. How did I get 0.8?
8%.
Yeah, how did I get 80%?
Because 0.12 plus 0.08 minus 1 is 80.
You're thinking it perfectly. You're saying it backwards. So 1 minus 0.12 times 0.08 is 0.8. Okay, that's what you're thinking, right? Okay, yeah, so what you were thinking was right. So the idea is what you typically do is you say, well, what's the probability of all the rest of the stuff? And that is 20% or 0.2. And then 0.8 is 1 minus 0.2, or 100% minus 20% is 80%. So you do often have to do the computation for the final probability. And one of the big rules of probability that you got in the last chapter is that if you add up all the probabilities, you always have to get one. There's a 100% chance of something happening, right? So that's where that comes from. Any questions at all on taking an example like this and writing down a probability distribution table? And by the way, it's always going to have, either I got 2 rows. You could write it in columns if you want, whatever fits better on what you're doing. So on this page, it fit better to write it in rows, but some people do it in columns if that fits better. So that's more fitting, but you should label it X and P of X. Any questions on the probability distribution table?
This example, is it something that we have to come up with for our homework? Does this count as one?
Yep. Yep. And in fact, not what you're thinking about, I hate the word homework. In this class, everything is homework, or it might be, I don't know, it could be beach work if you were like me as a student, because I went on the beach and did my work when I was in San Diego, by the way, not Tahoe. It's snowing. It was, I don't know if it's still snowing, but it was snowing. But wherever you're doing it. So I like to call these the discussion assignments. Yeah, so the discussion assignment, you have to do something like this. And what I strongly recommend is you come up with your idea on a piece of paper, answer your question, but don't submit your answer ever. But if you can't answer your question, it may not be a question that works. Does that make sense? Okay, but then submit your question, and then hopefully other people will be able to answer it. Okay, and if you just don't understand it much, that's when you post on the Q&A forum. I don't understand how to do a probability distribution table of this kind of thing, or whatever it might be, and then I can help you out. Okay, but I recommend you do it on a piece of paper. Do not post your own solution. Okay, that's really important. And then, and I want to mention, because a lot of people don't listen, but I don't know what I can do. Make sure it's done by Thursday for your initial post. I take off points if it's after Thursday. So that's just a note. And then you get to reply to someone else with the full solution. And the next part is what I'm about to do. And that is called the expected value. Okay, often called just the average or the mean. But it's expected value is a special one that you use when we have a probability distribution table. Okay. It turns out you can actually use it for continuous, but not in this class. You need calculus. So, but for this class, we can do this expected value with the probability distribution table. And what the expected value pretty much tells you is if you do it a lot of times, then it is likely, okay, so if many trials are done, so in our case, if we had many customers that came and looked at cars, then it's very likely, okay, and by the way, with this class as elementary statistics, we keep it vague, so just very likely, you don't have to get any kind of probability of likeliness, but you should be able to say and understand kind of the idea of being likely. Okay, and similarly, what does many mean? Just for this class, just many. That the average of the trials will be very close to the expected value. Okay, so this is what I call a template. In fact, let me put that word template. So it means don't just write this down word for word. You should always talk about what it means for the particular example we've got. Any questions on that? Okay, the formula for the expected value is right here. And I've done this before to you. You don't need to know this formula. Do you know why?
Here's a calculator.
Yep, that was my job. My job is to program a calculator so that you can take a probability distribution table and create the expected value. Okay, using the calculator and standard deviation, by the way, which is even more difficult. That's actually pretty brutal. Okay, but since you often have to do both, you might as well just use a calculator. It's a whole lot easier. So the calculator, by the way, I also tried to make my calculator very, very easy to figure out what you need to do if you know what you're supposed to do. So what number do you think I need to go on the calculator?
6.
Hmm?
6.
Yep, number 6. So expected value and standard deviation. Okay, so I tried to make all the titles, okay, which is very different than like a handheld calculator. It's never going to have words like that, you know, on your keyboard, you know, on the keys. So they'll just have like EV or something. So it's expected value and standard deviation. You click that. And you'll notice again, this is in columns instead of rows. That's fine. That's what I mentioned. Sometimes you'll do it in columns, whatever fits better. And it turns out columns fits better on this program. And then we put the different X's in and the P's. So our first was 190 and 0.12. 190.12. The second was 290 and 0.08. And the third was -10 and 0.8. Any questions on just typing them in? And then I hit calculate. Didn't look too hard, was it? Okay. And most people don't find this hard. I'll let you know when most people find it hard. This is not one they find hard. Okay. And we get, I'm just going to round to the nearest whole number because what are the units here?
Dollar amount?
Yep, these are dollar amounts. And probably are good enough knowing that it's $38. Okay, and it's standard deviation is 98. You know, yeah, it's 0.4683, but good enough to just say 98. Okay, in terms of you know, real life stuff, $98. So now let's interpret the expected value in the standard deviation in terms of this particular example. So again, see these words, many, likely, average, and close to. So I'm going to tell you now, I'm going to tell you now that you will lose points if you do not have those words in your explanation when I ask you to interpret the expected value. So I want you to do me a favor, and I want you to do this too if you're watching this on YouTube. You'll do it on paper. In your chat box, right? I promise to use the 4 words. Can you write that in? I never know exactly how to make it happen, but maybe this will help. Make sure that you do it. Can you put in I promise? I'm not asking you to some promise thing that would be against your religion or something. Okay. So I want you to use those 4 words. Okay. Okay. So I'll do this here and there. So when I have you do that, that means it will appear. Okay. It will appear, and more than once, by the way. So it's really important to know those words. So here's my interpretation. I'll pop it up a little bit. So if the car salesperson has many customers, there's the word many, then it is very likely that the average profit will be close to, and I'm going to put the number in, and the number was
38.
$38 per customer. Any questions on interpreting this expected value? Okay, I'll let you know in business, the expected value is everything. Okay, the expected profit, that's mostly what matters. I shouldn't say everything, but it's most important is a better word. It is the most important thing in business. Okay. But the standard deviation is also important, even though it's not quite as important. Okay. But sometimes it's actually in certain situations, it is more important. I'll explain it in a bit. Okay. So if you look at the standard deviation, that was 98. If you remember, notice that's a lot of money. Given that you're only making on average, with many customers, close to $38 per customer, it fluctuates a lot. Does that make sense? So in particular, that means that there's going to be some days where actually you're paying to work. But there's going to be other days where you make a lot of money. Do you see how that works? Okay, but on average, over many, 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 customers and days with many customers, you're going to make a decent living. Okay. And again, I'm not a car salesperson, by the way, but let's say it takes a half an hour to show a customer car and, do your spiel. Then you're making what, $76 an hour on average. Do you see how that works? If you have 2 customers an hour, but there'd be some hours where you actually lose money, a lot of hours. So the standard deviation kind of gives you that idea that, yeah, $38 an hour is likely to be close to the average if you have many customers, but it's not stable in the short term. And that's because the standard deviation is so big. Yeah, standard deviation is a dollar amount. And I will tell you, the variance is the square of the standard deviation. So the units of the variance would be square dollars, which is totally useless. Right? No one even knows what a square dollar is. I don't know what one is, do you? So just to let you know, if you ever think you're going to interpret the variance, think again, because the invariance doesn't have any practical, non-mathematical interpretation, but the standard deviation does. Any questions on that? So that's an important example. Okay.
I actually have a question. I mean, can that standard deviation go up to like $1,000 or something like that? Or is it?
Oh, yeah. Yeah. Do you remember the example I gave last week? The lottery. Yeah. So if you're looking at the lottery, it has a huge standard deviation. I'm not sure if it's $1,000, but it's a giant standard deviation because you win like, $300 million or something like that, right?
Mhm.
But most of the time you just lose. And then sometimes you win a little bit.
But when you look at this standard deviation, I mean, it seems like, are all standard deviations relative to the variance or relative to like the range?
So they're the same units. That's important. So it's always the standard deviation fits the units of the survey. That's the biggie. So in this example, the standard deviation units are dollars. Okay. Whereas let's say you're you're a nurse, and one of the big things nurses do is blood pressure. Standard deviation is not going to be dollars, right? What's it going to be?
Millimeters of mercury.
Okay, millimeters of mercury. Yeah. Do you see that?
I'm not asking
and that would
more
be if you have a high standard deviation in with your people, that's probably bad because that means you got some people with really high blood pressure and people with really low blood pressure, which is both bad. Do you see that? So if you have some kind of test case, then, but that would be a continuous variable, by the way. Does that make sense? So standard deviation is important. Sometimes you want it to be big, sometimes you don't want it to be big. It really depends on what's going on.
Okay, wait, I'm sorry. But in this case, you said that the standard deviation is quite big.
Yeah.
So
relative to the mean.
Am I measuring 98, the number like $98 against the potential of $290?
Actually, you're measuring it from the average here.
Sorry,
saying-
that was so obvious.
Yeah, your average income is $38 per customer. Do you see it? It's likely to be that with a lot of customers. It's going to be close to 38 bucks. But the standard deviation is a lot more than that. Do you see that? So it's usually relative to the expected value that's most important. Does that make sense? Okay, so let me continue on because we have more to do. Okay, so again, the standard deviation is really large. The salesperson, if they're smart, they need to have some money in the bank because there's going to be days where they're not making any money and days where they make a lot, but you want to make sure that you don't run out of business. In fact, one of the biggest reasons why businesses actually fail in their first year, which is I think over 50% of businesses fail in the first year, is the standard deviation is large and they don't have enough money to back up their loan when things go bad and then they fail. So that's a real common thing with businesses. Okay, so in this case, this example, you want to have a lot of money in the bank. Okay. All right. So let's do another example. I think we have time. I'm going to do this one kind of quickly, though. So you've been offered a life and dismemberment insurance policy. Okay. And you can think of it in two ways. One is you as the customer, or if you were an actuary working for the insurance company. It costs $1,000 per year. The policy pays their heirs $100,000 in the event of death. Obviously, you don't make any money if you die because you're dead, but your heirs, like, can make money. Okay. And $50,000 in the event of dismemberment. Do you guys know what the word dismemberment means? It's an insurance word. It's not a happy word, by the way. Okay.
Loss of a limb or a digit.
Yeah, loss of a limb or digit or any kind of body functionality, basically. So that means you got some kind of bad thing happened. You're still alive, but now maybe you're not able to work anymore because you lost, you lost your hand or something. Okay. The actuaries have determined that you have a 0.3% chance of dying this year. Okay. And a 0.5% chance of dismemberment this year. Find the expected value in standard deviation, interpret the expected value, explain why the standard deviation might indicate that it still might be a good idea to purchase insurance, depending on what your situation is. So let's do our table. And I'll just write it quickly. So we're going to have X. And the X's that can happen, again, you got to pay $1,000, but your heirs get $100,000. So just like the profit idea, that's what matters, would be $99,000. And then if you have dismemberment, that means $49,000. And then if you didn't have either of those, that means it's negative $1,000. Okay. By the way, of these three, which is good?
Negative $1,000.
The negative.
Yeah. If you don't think the negative is, then I need to talk to you about the health services, mental health services that we have at our college for all students. The negative needs to be the good one because that means you didn't die and you didn't have your arm chopped off or something. Okay. So you actually hope that the insurance was a total waste of money. You always hope that with life insurance, just let you know that. Then we're going to have P of X. Okay, well, we had a 0.003. Remember, you got to move the decimal over twice. That gives us 2 zeros before the 3, and 0.005. And then 0.003 plus 0.005 is 0.008. 1 minus that is 0.992. Again, you're always welcome to use a calculator. I tend to be a human calculator, so I can do it in my head, but you're not expected to have to do that. Okay. Then we pop it in. And by the way, just note, just a reminder, I made sure on every one of these has a scientific calculator button. So if you want, you can click that, and then it just becomes a regular old calculator also. It adds on. Okay. By the way, if you need to, instead of like erasing all these one at a time, just let you know with this calculator, the easiest thing to do is just hit the refresh button. And that erases everything. So the refresh button on your computer is the clear button, basically. So that's why I don't have a clear all. Okay, so then we just put our numbers in, and that's 99,000.003. Okay, and by the way, oops, zero. Don't put commas in ever on this calculator. Don't use commas for 99,000. That's what I mean by no commas. Is just type in the numbers. And then we had 49,000.005. And then we had negative 1,000. And that was 0.992. Let me just pop it in. Okay, so, and I'm not going to type this all out because again, we only have so much time, but I'm going to say it. The expected value is negative 450. Units again are in dollars on this particular one. They won't always be in dollars, but these examples were. So you would say that if many people purchase this life insurance, okay, then it's likely, or very likely if you want, that the average profit per policy will be close to negative $450 per person. It's probably easier is to get rid of the word profit and turn it into loss. And you would say if many people purchase the policy, then it's likely that the average loss per person is close to $450. Any questions are likely to be close to $450. So is it a good idea to buy life insurance?
I think it depends on the situation.
Yeah, it's a tough question, right? If all you cared about was the average, then it's a terrible idea. Okay. I had life insurance. Anyone know when I had life insurance? When my daughter was young. Because I did not want to, unfortunately, it didn't happen. I didn't die. I didn't want to die and then have my daughter not be able to bury me, for example, and then be able to live a few years at least, without having a salary of mine when she's growing up, kind of thing. Does that make sense? Okay. But then on the other hand, as a student, I didn't have life insurance. Why should I have life insurance? If I die, then, yeah, my parents would cry, but but it's not like anyone needs my money when I was a college student. Does that make sense? So sometimes that negative 450, just because it's negative doesn't mean it's always bad. Okay. The standard deviation is really big, and that you would expect. Okay. Now for the company, let's go on the side of the company now. Is this a good policy expense if they have a good clientele for the company? Then the average is everything. The answer is yes. Now the standard deviation is big, which means they got to make sure that they can afford to pay it off when they need to. But it won't happen that often. And I'll let you know recently, some horrible news is that in California, not life insurance, but house insurance has gotten a really, really big standard deviation with a really high, with a change in expected value from what it used to be for the dollar amount that they used to charge. Anyone know why in California?
Wildfires.
Yeah.
More fires. Yeah, it's more fires. And that's why insurance companies are having all kinds of issues trying to figure out what to do. So just let you know that that's the kind of stuff that's happening. Okay, let me continue on. Let me go to the second half of chapter 4, and that is binomial distribution. So let me make this big. So a binomial distribution comes from multiple independent trials of a yes/no question and measures the number of yes answers. Okay. And sometimes it's not literally a yes or no, but you can turn it into a yes/no. Okay. So sometimes it might be, live or die. But that can be turned into a yes/no. You can turn that question, instead of did the person live or die, you could just ask, did the person live? And that's yes or no. Or did the person die? And that's also yes or no. Do you see that? You get to choose which way. Okay. So I want to let you know, yes is not always a good thing. Doesn't mean a positive thing happened. It just means the answer was yes. Does that make sense? Did your house burn down in a fire? Right? If you say yes, that's not a good thing, right? Okay. But, and this is something to be careful of, the number of yeses mathematically is called number of successes. Even if success sounds like it's always a good thing, don't shoot the messenger on this. I didn't make up the language, but you'll hear successes for number of yeses, and that's not the number of good things that happen. It just means the number of yes occurrences. Does that make sense? Okay, so binomial comes from that. It happens in many, many cases. Anytime you do a survey where it's a yes/no question or only two possible outcomes, then that's going to be binomial, because you're interested in the proportion or the number and the related proportion and number of yes answers. So here's an example that I've got. Okay. And let me put this in. I'll make it a little bigger for you. This one I typed in, and this one I looked up. This is real. Whereas a lot of examples I just make up, like numbers, like the car salesperson. I don't really know how much money people make in the car salespeople, but this one I looked up, and there have been 142 years in recorded history of global temperatures. Okay. And that's just, I spent some time researching that. I don't know about you all, but I care about climate change. So I've done a lot of research on it, not that I can do change the whole world, but I can do my little piece. And part of that is teaching you guys. And 142 years is what we've got in terms of recorded history. Okay. If the next 20 years, should be in, not if, sorry. In the next 20 years, if the weather is random, find the probability that at least 10 of them will be in the top 10 of the prior 142 years. Any questions on that idea? Okay, so notice what you're doing is you're looking at each year and you're saying, is that year? So is the year, 2010, for example, was that in the top 10 of the warmest years on record? Does that make sense? Okay, and that's a yes/no question. Either was in the top 10 or it was not in the top 10. So that's how you turn that into a yes/no. Any questions so far? Okay, and what we're interested in is the probability that n will be at least 10. One of the hardest parts about this particular chapter, and my definition of hard, by the way, is students don't get it right. Sound good definition, is actually reading things like at least and turning it into an equality. Okay. Or at most, or, worse than, or better than, or faster than, and understanding what kind of inequality you get. Does that make sense? So that's something you need to practice with. And it's hard because it's English language more than math language. Okay. So the probability of a yes answer, if it was completely random and you grab one out of the 142 years, the probability of being in the top 10 would be 10 out of 142. Right? Because there's 10 years that can be in the top 10, and there's 142 years in recorded history. Okay, and I popped that in my calculator, I got 0.07. Any questions at all on this example of binomial where we got a yes, no question? Okay, so that's the probability of a yes. N is 20. And we want, what is the probability that X is at least 10? So X is greater than or equal to 10. Now, another way of writing that is that the low is equal to 10. That's the lowest number of yeses you can get and still be greater than or equal to 10. What's the highest number that you could get and be greater than or equal to 10?
20.
20, because that meant, okay, means all of them, okay? And we're kind of random without replacement is the idea. I should write high. And then the number of trials, that's N, by the way. Oops, high was 20. Number of trials was also 20, which is common, by the way. Number of trials or your N is either going to be the low or high. Not always, but it happens a lot, especially in later on when we do statistics on this stuff. Do something called confidence intervals and hypothesis testing, then we'll do that kind of stuff. All right, so we want to find the probability. And here's what I'm not going to do. I'm not going to tell you about the underlying math, which means, what's the next step?
Calculator time.
Yep, calculator time, okay? There is underlying math, and most of you would like cry if you saw it. It involves factorials and all kinds of weird stuff, okay? What do you think we're going to go to? The hint is I tried to make these in order, the way that we do things.
7.
Yeah, number 7, binomial probability. And I tried to make this easy. The low was 10. The high was 20. Number of trials was also 20. And then if you remember, the probability was 0.07. And I hit calculate. What does it give us? Okay, it gives 0. And I want to let you know what that means. Okay, it doesn't mean it's perfectly 0, but it means that if you round to however many decimals this gives, like 7 decimals, it's all zeros. It's like 1 in a trillion chance or something like that, which rounds to 0. Okay, so this is why there is no question that climate change has happened. Because when you calculate these probabilities, it's such a low probability, it's unquestionable. Does that make sense? Okay. What this doesn't do is talk about why the climate change happened, but it does show that it happened. Okay, the why it happened, that's where you have to do a lot more work with correlations and more stuff that we're going to do in our class. Okay, but this is an example. This is evidence, like very, very incredibly strong evidence that we have climate change and global warming, which means average on Earth, not individual towns, but average on Earth, or doesn't mean individual days either. Okay, any questions on that? Okay, and again, there's lots of binomial problems that could happen. This was one example. I like to give like real life examples that I care about, and maybe you don't care about climate change, but I do, so sorry about that. You're going to get my way of caring about things. But other things could happen. Let's suppose that, you know, you're working in a hospital and you found out that, you know, under normal circumstances, say, you know, 1 in 5 of the patients after surgery are going to have some, you know, miserable aftermath. Okay. But instead, what you want to do is you want to try some new technique and see if that's helpful. Okay, and let's suppose you did a study on, say, 30 patients. Let's go 35 patients. You did a study on 35 patients, and you found out that 3 of them had some horrible thing happen. Okay, well, what's the probability that had it been nothing to do with your new treatment idea, that you would have 3 or less? Because 3 is good, by the way. 3 out of 30 instead of 6 out of 30, which you would expect. So then you would say that 0 would be the low, 3 would be the high, and the trials in that case were 30. And the probability, if it had nothing to do with your technique, in other words, if it was like everything else, then it should be 1 in 5, which is 0.2. And you calculate, and you get about 12.27%. So low, but not that low. So in that case, there is a chance that it had nothing to do with your technique. You might have just gotten lucky and not that many patients had it. Do you see that? And that's where your sample size might have been a little bit too small. Okay, so you're not able to get FDA approval because, yeah, you got, pretty low chance, but not low enough for it to just be random chance instead of your particular surgery. So any questions on that idea? Okay, let's move on to I don't have time to do all the examples, but there's others. So I just want to mention a couple things. I'll read this, but not do the whole thing. So 42% chance, Californians, I wrote this a while back. Maybe I should change it now, but 42% chance have received at least 1 dose of COVID. I wrote this a while back. If 15 randomly selected Californians are surveyed, what's the probability that between 5 and 10 have received at least 1 dose? So in this case, the low will be 5. The high will be 10. Any questions on that? At least 7. Then what's the low?
7.
And the high would be?
15.
Yep. Less than 9. What's the low?
0. And then 9.
If less than 9 received at least 1 dose, what's the smallest number that could have received 1 dose?
0. No?
Yeah, 0. So low would be 0. What would the high be?
8.
It
8.
wouldn't be 0 and it wouldn't be 9.
It'd be 8.
It'd be 8. Because 8's the highest number less than 9. Does that make sense? So this is where people make mistakes. This is where I'm going over this part. Exactly 6. What's the low?
6.
6. What's the high?
6.
Yep, the low is 6 and the high is 6. Got it? So you're responsible for being able to read those words and figuring out what the low and the high is from the words. Any questions on that? Once you have that, putting in the calculator is really easy. But where people make mistakes are things like less than 9 and they put 9, but it should be 8. Okay, so you got to get used to, and practice is what matters, and there's lots of practice you can do. Okay, let's move on to chapter 5. And chapter 5 is even shorter than chapter 4, by the way. There's really only 2 small topics. And the idea of chapter 5 is continuous distributions. So the first thing is that with the continuous distribution, those means you can't list them, right? That was the definition. Can't list all the outcomes. So if you can't list the outcomes, you can't build a table. Is that clear? Because a table is a list. The first row or column is just a list of all the possibilities. If you can't list them, there's no list. Does that make sense? So what you typically do is you draw a picture and you draw a graph. Okay. And who remembers what the shape of this graph that I have right here is? Starts low, goes up, and then goes back low. In one word.
Normal?
Yep, this is a normal distribution. Okay. This is the most common continuous distribution. And it's the most, not just most common, but also most important. But you won't understand that until we get to chapter 7. And we're on chapter 5 right now. So it's another couple weeks. And then we'll realize why normal is so important. But right now, just trust me. Sound good? Okay. And it turns out that if you want to find out the probability of being between two values, between the low and the high, you draw the picture and you shade in the region between the low and the high, and the area under the curve shaded in is the probability of being between the low and the high. And let me ask you again, just say yes or no. It's not important. Any of you have you had calculus? It's not a requirement of this class, but put in the chat. Okay, usually it's mostly no's and usually one yes. That's what I usually get. That's what we're getting. So just let you know, if you haven't had calculus, like close your ears because I don't want to scare you. But if you've had calculus, the probability is the integral from a to b of f of x dx, where f of x is the distribution function and a and b are the low and the high. Okay, if you haven't had calculus, just pretend you didn't even hear me because I'm not allowed to make you understand it. And but if you had calculus, hopefully you understand what I just said. So just know we're not going to be able to do the calculus. That's my job, which means I make the calculator for you. But there is one situation where I expect everyone to be able to find the area under a curve. And what is that situation? What kind of special curve do you know how to find the area of?
Symmetrical?
Actually, normal curve is symmetrical and definitely you need calculus. And by the way, just to let you know, not only do you need calculus, by the way, this can't be done in closed form with integration with any integration techniques. With a normal distribution, you have to use power series if you know what that means. If you don't, that's okay. So no, symmetrical is not enough because this is symmetrical. It's the one thing you know how to find the area of in geometry.
There's no curve, it's just a flat
The
one.
first one you learn. You probably learned it in 4th grade.
Circle?
No, before circle, the first one. The square or rectangle. So I'm going to be a little more broad than square, is a rectangle. So that means that if this curve is just horizontal, if it was horizontal, then you all are at least supposed to know what the area of a rectangle is, because you have a rectangle. What's the formula for the area of a rectangle?
Base times width, isn't it?
Yep, base times width. I usually use a base times width is fine. Length times width is fine. I typically use base times height. Whatever you want to call it. I don't like length because my L looks like a 1 and then it's really confusing to everyone. So I use B. So I use area equals A equals BH. So if you see me type that out or write it, then BH is what the area of a rectangle is. So a uniform distribution. So when you hear the word uniform in English, not math anymore, what do you think of?
Either clothing or
Yeah, and what about the clothing? And what about the clothing? That's the important thing.
Generally in some sort of group like military or police, firefighters, or something
And
belonging to one.
And what could you say about their clothing, the way they're dressed? If you have 17 people all in the
They're all the same.
All the same. Good. That's the words I wanted to hear.
Yeah.
The same. Okay. So a uniform distribution means that if you take any piece of the x-axis and look at the area, if the amount of x value you've got is the same, then so is the area the same. And that's that's actually that's the definition of a uniform distribution, is the probability between any two equally spaced numbers within the region that it's decided is always the same. Okay. So let me make it bigger so you can read. And I'll pop it up a little bit because I know that's sometimes a problem. There we go. So a uniform distribution from A to B, you have to have a low and a high with the uniform distribution, because the area, the total area has to be 1, because you have 100% probability that you're between the low and the high, right? The lowest and the highest. Okay. It's a distribution such that any two given intervals of length k that are contained in AB has the same probability of occurring, and any interval outside of AB has 0 probability. Okay. And the distribution curve gives the rectangle. And this is important because I'm going to ask you to do this, is that when you're talking about distribution, if I ask you, write down the distribution, you start out with a variable. So in this case, which will be different, by the way, in a couple chapters, our variable will be x. And let's see, I usually don't get anyone that knows this, but let's see if you know it. How do you read that symbol? It's a symbol on everyone's keyboard. It's usually,
Approximately. That's what I.
good try, but no, that's a math way of reading it. But what's the symbol way of reading it?
Tilde?
Hey, someone knows. I usually don't get anyone who knows. Tilde. Okay. And if you speak Spanish or read Spanish, actually, it's what you put over the N for the ñ. Okay. And I've asked them, I think there's no word for it in Spanish because none of them seem to know. I thought everyone would know in Spanish because they all use it all the time. But for some reason, there's no word for it in Spanish. But it's a tilde. So it's x tilde. And by the way, that shift just above the, just to the right of the 1 will give you a tilde on your keyboard. And then U, what do you think U stands for? This is an easy answer.
Uniform?
Here's a hint, it's in red.
Uniform?
Uniform. U for uniform. Okay. So X tilde uniform, U, and then you put the low and the high of the full rectangle. Any questions on that? Okay, we're going to be using this notation a lot, where it's going to be X or something, tilde, then the first letter of whatever distribution. You're going to see U, but what are you going to see more often? What I told you the most important one was? N, normal. Normal distributions are the most important. So I'm going to keep saying that because we'll get there. Next week and the week after, that's all we do is normal distributions. So, but this time is uniform. And then parentheses A comma B, which is the kind of the two numbers you need to know. And then M parentheses. All right, so here's an example. Okay, suppose that the time that students spend with a math tutor is uniformly distributed between 10 and 120 minutes. Okay. By the way, remember what it means if I say suppose?
It didn't actually happen. All right.
Yeah, it means I totally made it up. Don't quote me on it. Don't cite it as any reference. I'm just making up numbers. Okay. And in fact, I know it's not uniformly distributed, but I need to do something. Okay. There's not a whole lot of things that are truly uniform, but they're the easiest ones to do in terms of math. So we can actually do it. So it's between 10 and 120. So we can write X tilde U 10 comma 120. So A, if a randomly selected student who used a math tutor is observed, find the probability that the student will spend between 30 and 70 minutes with the tutor. Any questions on the question? So it's a step-by-step process. Step 1, draw a picture. Got it? And as I've mentioned a bunch in the last 15 minutes or so, the picture is going to be a rectangle. Got it? It's going to be a rectangle. I put 10 and 120 because that's the lower and the upper bound for all possible number of minutes that people can use a math tutor. Okay. We don't know the height, do we? So I put H. H is a good letter for height. Hopefully I don't have to explain why. And any questions on this picture? Okay, then I use a very important fact, and that is the probability of anything in the universe happening is always 100% or 1. there's 100% chance that if you randomly pick a student, they're going to spend between 10 and 120 minutes with the tutor, because that's what this says. Probability is the area. So I can say that the probability that X is between 10 and 120 is 1. Any questions on that? But 1 is the area, which is the base times the height, because it's a rectangle. So stop me if you don't understand. Now the base, I can do 120 minus 10 will give me the length of the base, right? Because if I went from 0 to 120, that's 10 too much. So I subtract 10. So that's 110, and the height is h. That's what I'm trying to figure out, at least at the beginning. So I know that 1 equals 110h. I divide left and right by 110, and I get h is 1 over 110. Okay, so by the way, this is the first algebra we're really doing in this class. And we don't do that much algebra, but we have to do it a little bit from here to there. Okay, and anything advanced, I can't have you do, but this, I don't consider this advanced. This is base times height, and all you're doing is dividing by a number on both sides. So this should be very basic algebra. Any questions on how I arrived at h? Okay, I'm not done yet because I haven't reached my goal, which is to find the probability that a student's going to spend between 30 and 70 minutes. So now I draw another picture. So now I redraw the rectangle. I draw 30, I draw 70, and I shade in between 30 and 70. Any questions on that? And I need to find the probability of being between 30 and 70. That's the area of the shaded in rectangle. Again, area is base times height. I always like to write BH because that helps me kind of get my, things in order. The base now will be 70 minus 30. The height, that was why we did all this, was 1 over 110. And 70 minus 30 was 40. So you just get 40 over 110. Now, if you had to do this for the weekly assignments, you stick it in a calculator, and you go 4 decimal places or so, and you pop that in for the chapter assignments. Any questions at all on this example? Okay, now let's do part B. Find the first quartile for the time that students spend with a math tutor. Okay, so what's the definition of first quartile?
The first 25%. The first 25%.
Yeah, 25. What about 25%?
It's the lowest 25% of whatever sample you're looking at.
Right. So 25% are at or below that number. Does that make sense? So then I can draw a picture, and the picture is really important. So it's the same rectangle from 10 to 120. I don't know the first quartile, so that's when you use a letter. Let's use X because it's math. But what I do know is that 25% is to the left of that value, which means that the area of the rectangle to the left of this X value is 0.25. Any questions on how I arrived at that and my reasoning behind it?
My question is, if it's evenly distributed, can you just cut it into like 4 chunks? And
Okay, that could work on this example. But what if I asked you for the 73rd percentile? So by doing this example this way you can do any example. Does that make sense? And this also gets you to remember what quartile means. So there's a reason why I'm doing it. So learn this way of doing it, because like on a test, I would ask you to do it in the 73rd percentile or the 22nd percentile or something where chunks don't work. Does that make sense? Okay, and this isn't any harder, it turns out. So again, we just write down a area equals base times height. Area we're given is 0.25. You see that? The base now is again the right minus the left, which is x minus 10. The height we already found was 1 over 110. So any questions at all on how I came up with this equation right here? Okay, now it's very basic algebra, but some people have trouble with it. And that is we need to solve. So we need to get rid of the times 1 over 110. You do that by multiplying left and right by 110. So you get 0.25 times 110 equals x minus 10. And then you add 10 to both sides. And that's it. And then you pop it in a calculator. And you get 37.5. And one thing you want to do always is take a look at it and see if it's reasonable. So if you kind of made a mistake and you end up with 375, like you lost the decimal place, you look at your picture and it's like, that can't be right. 375 is like way over here. That can't be the first quartile. Do you see that? Because we know that x is going to be closer to 10 than it is to 120. So it's always a good idea before you put a box around your answer, you put it into the answer box to look at it and make sure it's reasonable. That's just a suggestion for the whole class, not just for this example. Any questions at all on part B, this example here? I'll let you know one good thing. This is very different than chapter 3. I've given you, a few examples, and all examples look very similar. So these are like template examples. You're always going to do the same process. They're not going to have the numbers 10 and 120. They'll have different numbers, but they'll look similar to this. And it might be, again, the 49th percentile or something like that, but same idea. You just have a 0.49 up here. Any questions so far? Okay, so now let's, I'm going to jump here because we only have so much time. If we have time, I'll go back to it. Okay, so here's a big theorem. Okay, and that is if x is uniformly distributed between A and B with low A and B high, then what does this symbol right here mean, this first symbol?
Population, standard.
Here's a
No.
hint. What does this symbol
Population
mean? Yeah, what does the symbol mean? That was not a coincidence. Yeah, it's a population mean. Got it? Okay, and how do you read it?
You.
Yep, and you might have seen at the beginning before I actually started. What did you all see? You didn't hear it. You didn't hear her, but probably saw my cat going. She didn't say mew though. She does sometimes if I had food over there or something. Okay, so this is mu, which is the population mean, and it's A plus B over 2, which makes sense, is that the mean is the average of the left and the right. If you have a rectangle, the middle is halfway in between. That's all that is. Any questions on this first piece? Okay, the second piece is sigma. Okay, and by the way, what does sigma stand for?
Standard deviation.
Yeah, the population standard deviation is the square root of B minus A quantity squared over 12. Okay, I will let you know that you probably do not want to see why it's true. But it's a formula that you should have written somewhere so you can get to it when you need it. Got it? Okay. And I'll let our one calculus student know it has to do with an integral, but it's too complex to get into in this class, so I can't do it. Okay. But kind of after, if you really want to see, I'll show you a whole integration thing that happens. But again, it's too much to, this is not a calculus-based class. So I'll let you know that happens a lot in this class. Okay, so that's the mean and standard deviation. So I got an example. And let's make it a little bigger. Okay, suppose that the number of ounces that people drink from the drinking fountain is uniformly distributed between 1 and 8 ounces, and that the number of ounces of water that students use to fill their bottles in the drinking fountain is uniformly distributed, okay, between 4 and 16 ounces. Okay, so notice that 1 and 8 for just if you drink out of the drinking fountain, and then it's 4 and 16 if you take a bottle and fill it. Those of you who've been to our college, a lot of our drinking fountains have both, but you've probably all seen it. Okay, you watch Thorn take a 2.5 ounce drink out of the drinking fountain, and Preston, okay, and by the way, Thorn and Preston were my students many years ago when I first wrote this down, and Thorn, kind of cool names. Fill his water bottle with 5 ounces of water before he runs off to class. Whose water usage is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? Any questions on the question first? Okay, we need to strategize here. We need a statistic that measures how unusually small something is. What's the statistic we've had in our class?
The z-score?
Yep, the z-score. So the z-score is a measurement of how unusual a data value is. So what we want to do, our goal, is to find the z-score for Thorn's drink, find the z-score for Preston's drink, and see which one is smaller, okay? And it's going to be particularly which has a bigger negative value in terms of left-hand side negative. Any questions on the question? Okay, so then we find the z-score, and you got to remember, we have a formula for the z-score. Z was equal to x minus mu over sigma. Okay, and again, you're not required to memorize really anything in this class, but you're required to make sure that you have the formulas available for you quickly enough, especially on your exams, so that it doesn't take you 45 minutes to go find a formula, because you'll run out of time on exams. So I recommend, putting the formulas in some nice place for yourselves. And z-score is one of them. Any questions so far? Okay, so now what we need to do is we need to write down their distributions. Let me put it on its own page. Okay, so for Thorn, let's start with Thorn. Thorn's distribution is uniform between 1 and 8. And that says so right here. Any questions on that idea? So for Thorn, we can say x tilde u 1, 8. Okay, and it helps. That way you don't have to keep going back and reading full sentences over and over again. If you write it in symbols, you don't have to read that part of the question again the whole time, basically. The mean, we had a formula. Again, that was way up here. A plus B over 2. So I just take 1 plus 8 over 2, which is 9 halves or 4.5. And then sigma, again up here, the formula, is the square root of B minus A quantity squared over 12. So sigma is the square root of 8 minus 1 quantity squared over 12. And you pop that in a calculator and you get about 2.02. Any questions on how I came up with mu and sigma? Okay, then we go ahead and we find the z-score. And again, Thorn took 2.5 ounce drink out of the drinking fountain. So for Thorn, we take 2.5 minus 4.5 divided by 2.02. And when you do it in a calculator, don't forget you need parentheses around the numerator, or your calculator is going to do it in a way that's wrong. So it's parenthesis 2.5 minus 4.5 and the parenthesis divided by 2.02. And that gives you approximately equal to -1. Okay, then we do Preston. Preston, it says, was uniformly distributed between 4 and 16. So I can write that x tilde u 4 comma 16. The mean is a plus b over 2 or 4 plus 16 over 2. That's 20 halves or 10. The standard deviation is the square root of 16 minus 4 quantity squared over 12. And again, calculators are good for that. And I got 3.46 when I popped it in my calculator. And then we find the z-score. Z is equal to the x, which was 5 because Preston filled his water with 5 ounces. So 5 minus the mean was 10, divided by the standard deviation, which was 3.46. And I got -1.45. So -1.45 is to the left of -1. It's farther away from 0 is another way of looking at it. So it's more unusual. It's not an outlier. You got to be less than 2 to be an outlier. If you remember that, z-scores have to less than -2 or greater than 2. So absolute value greater than 2. And this is definitely not absolute value greater than 2. It's not an outlier, but it's more unusual to be -1.5 than it is to be -1 for a z-score. So that means Preston's water usage was more unusually small. Are there any questions at all on this example of using the mean and standard deviation formula along with the z-score formula to do an example? Talk about how unusual something is. Okay, so by the way, hour and a half is always about what I want, in terms of the time. I don't want to kill you with like 4 hours of lecture. Hour and a half is kind of the, the goal. And I'm at 1:33. So are we done? What's left? The secret word. Okay, so the secret word is what's left. Okay, and you have, by the way, if you don't do the secret word quiz by Sunday, then you have to write a 5-page paper with, you have to do 5 pages of notes and email it to me. Okay, or it's a disaster for you if you don't do that. So it's a whole lot easier to just do the secret word quiz. So make sure you do the secret word quiz by Sunday so that you can not have to do the whole 5 pages of notes thing. And the secret word is likely. And the reason is that was one of 4 words that was important for what?
Expected value.
Yeah, expected value. So I chose one of those words as our secret word, and likely is one of those. Okay, so that's the secret word. So I can drop it now. So hopefully you write it down. And that's, again, it's 1:34, which is about the time I try to be done by-ish. So let me stop the share. Let me stop the recording.